So here we go. There we go. So back to this problem, right? Change in distance over the change in time. Well, I just need to figure out what the heck is the distance that's being traveled here, right? How far is it traveling? And from T2 and T1. So I have the position function, that S right there. So I'm going to write it like this, right? I'm going to say it's S of 2 minus S of 1. Where am I getting this S from? It's just what they named the function, right? They named it S. So I'm just going to say it's S of T, right? Where the number inside there represent what time it is. And when I plug in that time into this function, I should figure out how far it has traveled given that amount of time. In the bottom here, I'm just going to have 2 minus 1 because it's 2 seconds. 2 seconds, right? I don't know why I'm writing the units here. 2 seconds minus 1 second, right? So in the top right here, I'm hoping you guys will see that S of 2. I'm just going to be plugging in 2 in for T, right? So S of 2, let's do the work over here on the side. That's going to be equal to 1.86 times 2 squared. And since I'm dealing with a decimal, I'm just going to go ahead and plug this into a calculator and see what I get. So calculator hopefully turns on. There we go. And I get here 1.86 times 2 squared, right? And that gives me 7.44 meters. I hope you guys understand that, right? They're telling me that the units for this is meters minus, I'm going to do the same thing for S of 1. I'm just going to plug that into the calculator as well. It's going to be 1.86 times, this time 1 squared, and that's going to give me 1.86 meters as well. 1.86 meters divided by 1 second. So I have here the average speed that this thing is traveling by is going to give me 5.58 meters per second. That's the average speed that it's traveling at from 1 second to 2 seconds, right? Nothing too crazy, right? You guys have learned this before, right? This is not a new thing, I'm hoping, right? It's just a different way of looking at it, right? You've calculated the slope for so many points, but now you can actually see, like, if you're doing it with if it's the chart that compares time to position, that slope, that rate of change is actually the speed of something, right? The velocity of something, right? And I think that's kind of neat. You could just comparing distance traveled over time. That's essentially what it is when you're trying to, figure out how fast something's going, right? And you can calculate the average speed of something, which is kind of cool. And which, by the way, is how if you ever go on road trips, if that ever is a thing anymore after this whole COVID thing, if you go on a road trip, there's some roads where cops set up checkpoints, right? And they won't actually check, like, they won't pull you over to stop you or anything like that. They'll actually check like what time it is when you pass a certain point, and they'll have another car like a mile down, and they'll check what time it is when you pass that spot. And just having that information from when you started from here and when you finished to here, if you finish that within like a specific time, they can actually say the average speed that you travel is faster than the maximum speed. And if that's the case, they'll pull you over for a ticket. So I had a teacher who knew this, and he would speed right after he saw the cop and they didn't pull him over. He would just speed as fast as he could to get to the next one. And then before he would get to the next checkpoint, he'd just pull over and wait. So that way they couldn't time him for that. But I always thought that was just weird, because now you're just wasting time because you have to pull over to wait. But he was just that type of person who just liked to drive fast. So that was one way that he got out of those speed traps that are out there. All right. Anyways, I'm digressing. So let's go ahead and take a look at one more of these types of problems. And I just wanted to show you, when you find the average speed, it's not that different from finding something like the average rate of change that we did earlier, right? So let's go with this one right here. Let's say I was given, right, f of x is equal to 2 times sine of x plus e to the x, right? Yeah, he did play the system, but it was just like he pulled over and waited anyways. So it was like, might as well just driven the speed limit. But I guess, he wanted the thrill of driving fast. All right, so this function looks crazy, right? Because we got a trig function in there and we have an e to the x function. I'm hoping you guys realize it's not that bad. It's the same concept, right? So if I'm asked here to find the average rate of change, finding the average rate of change, right, on the interval, whoops, interval 1 to 4. The closed interval from 1 to 4, right? So if I'm asking for something like this, find the average rate of change on the closed interval from 1 to 4 for this function f of x, it's the same concept, right? Right? The average rate of change is just calculating your slope, right? From beginning point to end point, right? So that's going to be equal to, I just need to find out what's the value, what's the function value at the end. So I need to find out f of 4 and then subtract that from what the function value is at the start. In this case, the start value is f of 1, right? And this is going to be divided by the difference in your x values, that how far did it travel from 1 to 4. So it's just going to be the ending point, which is 4 minus 1. Okay. Now, you have a couple ways of doing these types of things. Hopefully you'll recognize that it's a trig function and I don't actually have radians here. I mean, it is radians, but I don't have any pi values there. So I'm not asking you to do sine of 4 off the top of your head. I'm not asking you to do sine of 1 off the top of your head as well, because no one really knows that. Everyone only knows like, oh, sine of pi, sine of 2 pi, sine of 3 pi over 4, things like that. Not many people know what sine of 4 is. So if you come across a problem like this, chances are you're going to need to use your calculator for it, okay? So for this one, I would say this is going to be equal to this first function, which is going to be 2 times sine of 4 plus e to the 4, right? That's the first function. And then the second part would be the same thing, except it's going to be 2 times sine of 1 plus e to the 1. And this is all going to be divided by 3. That's really a mess, right? But again, just type it into your calculator, do it piece by piece, right? So I have here, go ahead and turn it on. By the way, if you're taking physics as well as AP Calc, right? If you're taking physics alongside with this class, please make sure that you understand that your calculator has different modes, right? In calculus, you're going to deal with radians when you're dealing with trig functions. In physics, you're going to deal with degrees in there. So make sure you have degrees in degree mode for your physics class. And if you come to my class for calc and you just came from physics, please make sure you switch over to radians. That's actually a big deal. Make sure you are in the right mode for the right class. Okay. So that being said, I'm going to go ahead and type this in. This is going to be 2 times sine of 4, right? Close that off, plus e. For those of you who don't know where the e button is right here above the divide sign, but in blue. So you have to hit second and then divide to get the e there. Push the caret to make it go to the power. And I'm going to go ahead and press that 4. So that comes out to 53.084, right? Or 08, let's say. So 54.08 minus, and I do the same thing for the other one. And by the way, there's a shortcut for this thing here. Once you key in a equation, you could just hit second and enter, and you can go back and change those numbers that you need to. So I could change that 4 to a 1, and I could change that 4 that's in there into a 1. Press enter there, and this comes out to 4.40, and this is all being divided by 3. So I can type that in, 54.08 minus 4.40. Right, get that answer, then divide that answer by 3, and I get 16.56, which, by the way, is not the, it's not the most accurate. 16.56. It's close, but it's not the most accurate. Do you guys know why that's not the most accurate decimal I can get, by the way? What did I essentially do by doing it this piecewise? You guys know? What's an issue that I'm going to have here? We rounded. Yeah, we rounded in the middle there. So we're going to have a little bit of rounding error. If you guys want, if you have a TI calculator, right? And if not, I'm going to, if you have your Chromebooks ready with you right now, I'm going to, hopefully this will work. I don't actually know if it's going to work or not, but hopefully you'll be able to get it on your Chromebook today before you leave. I haven't tested this yet. You guys are going to see if it works or not. But when you get your TI calculator, check this out, right? If you plug the function into where y is equal to in your TI calculator, which is the top button right here when you hit y equals, you can type in the function right into this. All right, get out of here. So I can type this in here. This is going to be 2 times sine of x, right? Plus e to the x. So I can type them in my function into here, right? And then it'll store it. So you can graph it and take a look at what this graph looks like, but I don't really care about the graph right now. I can store this in there, and that's the bigger part. I'm going to second and quit out. And I can actually type in this equation right here, f of 4 minus f of 1, but I have it stored in my y equation. So you just hit alpha and then trace, and it pops up this menu right here, and it says y1. That's why I stored my equation into y1, right? But I want it evaluated at 4, for example. So if I type it like this, check it out. It actually shows me what I had as my calculation earlier, right? Which is 50. Oh, it's 53.08. Why did I write 54? Whoops. That's 53.08. Right? So why is that so important? I can actually type in this whole thing and have to do the whole calculation in one go, right? This takes a little bit of practice though, but it's actually kind of neat. So I can go ahead and press that. This is going to be y of 4 minus, right? Y of 1. See that? And that will do that whole subtraction for me, right? And then at the very end there, put parentheses around that whole thing and say, hey, take that whole thing and divide by 3. Take that whole thing and divide by 3. And I get out here 16.22777 and so on. So actually a better approximation would be 16.227 or 228. I would say that would be the better approximation of it, right? And that's the last of this part, by the way. We're not actually taking the limits of average rates of change just yet. That's going to be the next section, and that's why we have this right here. It's just to, how to calculate the average rate of change on there. I know that seems a little bit different from all the limit stuff that we were doing, but it's going to all connect together, right? So that's that one. Yeah. And with that, we actually finish up chapter 1. Yeah. So that means that you'll have your homework for 1.4, and then I'm going to be posting your review guide as well. So you got a couple things here. You have your review that I'm going to put onto Kami for you guys to fill out, and then you also have your review on Delta Math. So you're going to have a review on each of those. So please make sure that you your Delta Math review is already posted. That's going to be due, I think, next week on Monday or Tuesday. I forget. Same thing with your review guide. That's going to be due next week as well on, I think, Monday or Tuesday. Wait, you guys are third period. Monday. Because then your test is going to be, I believe your test is going to be next week. Wait, is it going to be next week or this week? I need to figure that out. I think I set your test up to next week. I wanted to do it this week, but that might be pushing it. I don't know. Would you guys be ready to take the test this Thursday? No one's responding. I'm going to stop this recording real quick.